This is your notes on motion and frame of reference, and you'll want to have your note guide out where you have skeletal notes to fill in. If you were absent, I either have this in the out tray for you, or you can simply print off the blank notes at home. And so on your paper, you'll see that there's places for you to fill this in. So first we're going to begin with motion. So the motion of an object is always measured with respect to a reference point. All right, so what is motion, though? So motion of an object is always measured with reference to a reference point. Motion and reference point are both vocabulary words that we need to understand in order to really understand what that means. So motion is when an object changes position compared to another object. Now, usually that other object that we use to pick is usually stationary. Oh, no, that doesn't make sense. So these are your notes, and you're going to need to have a blank copy of skeletal notes to fill in as you watch this. If you are absent, those are in the out tray for you. If you can print off, I've included a link of the blank notes, and you can print them off and complete them at home. But the motion of an object is always measured with respect to a reference point. And you'll see that if you look at your skeletal notes, there's a place for you to fill those in. Now, mind you, at any point, you can pause this video and get caught up in writing things down if I end up going too fast. And keep in mind, you can always rewind already. Take 3. All right, so you're going to need your blank notes that you received in class. If you were absent, they're in the out tray. I also have a link that you can print them out if you have access to a printer at home. Keep in mind, at any point during this slide presentation, you absolutely may pause in order to have time to write things down, and you may also review and rewind. So the first at the top, you can see that there's a place for you to put these words in your notes. The motion of an object is always measured with respect to a reference point. Now, there's 2 vocabulary words in that sentence, motion and reference point. And we're going to need to be able to describe those in order to understand what that means when we say the motion of an object is always measured with respect to a reference point. So the first question we may ask is, what is motion? Motion is when an object changes its position. Well, in order to note a change in position, you have to compare it to another object. Usually that other object that you pick is stationary. That stationary object that you pick is referred to as your reference point. Now, it's not always stationary, but typically what we do is we do pick stationary objects as our reference points. So, for instance, a pencil held in someone's hand may appear to be at rest, but to an observer in a car speeding by, the pencil may appear to be moving backward. So again, it depends on what our frame of reference is. I'm going to show you this video that some students created to just sort of show that when we pick reference points, how that affects what we think of as the motion that we're seeing, or what we think of the motion that we're seeing. fast forward.
That's called your perspective. But sometimes your perspective isn't always where it needs to be. That's why you can't always believe your eyes.
Hey, can I have some of that?
Sure.
Thanks.
Sure.
Frame reference video. Is Craig really spinning, or is it the camera in the background? If you guessed B, then you're correct.
Another example is, it doesn't actually look like I'm driving when I really am.
And in this case, I'm not actually driving.
Relative to me, Games isn't going very fast.
But to a bystander, they both are. Well, Davis isn't.
So in that video, you saw that they picked frame of references for us, and then we determined the motion based on the frame of reference that we were using. So what is, again, a frame of reference? And again, there's a place for you to fill this information in your notes. A frame of reference is needed to describe motion accurately and completely. And again, but what is it? A system of objects that are not moving with respect to one another. And I think sometimes the best way to understand frame of reference is to just use examples. And again, there's a lot of things that you can pick for frame of reference, but a meaningful one will always allow you to describe motion in a clear and relevant manner. Again, we can kind of better understand this definition through examples. So for instance, here we have relative motion. When we look at this picture, we see a train speeding by people on a platform. We're observing that motion based on the frame of reference. What are we using as a frame of reference? We're using a set of objects. We're using the platform itself. We're using the building around the train. We're using the people standing on the platform. Those are all the things that we're using as a frame of reference to note that the train is changing its position, that it is moving. Now, imagine, though, that you are sitting in the train. You would have a different frame of reference. So the people in the train looking at each other, they don't seem to be moving at all. So keep in mind, let me go back here really quick. Over here, if I'm standing on this platform like this person here, I would look at these people in this subway train and I would see them speeding by me again because my frame of reference is the platform, the building, the other people standing on the platform. However, if I'm in the train, I could be using a different frame of reference. I might be using the other people in the train with me, this seat, this person, this person. When I look at this set of objects, they are not moving. As a matter of fact, if I could just blacken out those windows and I was on the train, I would think I was not moving at all when I looked at my